So, as I mentioned, for this unit circle, it is a unit circle because it does have a radius of 1, right? So keep that in mind when you hear a unit circle. What is the unit part? That means the radius is automatically 1. So that gives us a few coordinates to work with. We'll know that this is going to be 1, 0, right? And if we go up 1 unit vertical, right, that would be 0, 1. And if we go a unit to the left, which is 1, it's going to be -1, 0. Right? And if we go 1 unit down, it'll be, you guessed it, 0, -1. Okay. So we can get a few coordinates fairly easy, just by knowing it's a unit of 1. What's going to come later is what's the coordinates of all the 45 and 30, 30, and 60 degree increments. What are those coordinates as well? And that has something to do with sine and cosine that we'll talk about another day. Okay. So a little reminder, when it comes to circles and unit circles especially, they have some symmetry. Okay. So if I go, let's say some degrees, let's say 30 degrees right here, and that has some coordinate of x, y, right? Let's just say that's 30 degrees right here. If I go 30 degrees the other way down here, it acts as a reflection across the x-axis. So the x-coordinates are identical because they're lined up, right? But the y-coordinates will be opposites because this is the positive territory above and this is negative. So there's some symmetry with this system, right? Something just to recall. Another thing you might need to know or recall is that these quadrants have names. This is the first quadrant, second quadrant, third quadrant, and fourth quadrant. Always counterclockwise or anti-clockwise. The poles, right? The poles are not in a quadrant. So some of your questions might ask you this, like, what quadrant is this in? If it happens to fall like on, 90 degrees, you'd say not in a quadrant. Okay, not in a quadrant. But that's the basics of the circles and unit circles and the symmetry of circles. And we can go back over here and let's look at the equations of circles. Yeah. So down here, recall that we have a general equation of a circle, right, which is right here, but what we're doing really is putting in the origin, which is just 0, 0. So that means h is 0 and k is 0, and we already know our radius is 1. So this simplifies really quick, right, which is really nice. So we got, let's see here. In general, it's just x squared plus y squared equals 1, right? And that's the equation of a unit circle. And with this, we can start doing a whole lot of things. It looks very similar to Pythagorean theorem because they're all related, and that's what we're going to tie in all together. And just to reiterate, the circumference of a circle, we already know is from grade school, is 2 pi times r, sometimes pi times d, but 2 pi r is more common. But once again, of course, our radius is 1. So going back, this is why there are 2 pi radians all the way around a circle, right? It's not just like, well, we kind of came up with it. It's, it's based on the formula we've known for years and years and years. Okay. Now, the reason why we use radians and not degrees is going to be apparent a little later on. It's because things are periodic, and when things repeat, it's much easier to be in radians and do a lot more work with radians because of that. It's, so we'll get to that a little later. I think there's one more thing. I think that's pretty good. Yeah, it's pretty good. Cool. All right, so next, let's get into this part, what's called the wrapping function. Okay, so the wrapping function, I want you to think of the GIF I was showing you earlier. Let's see here, right there. Right, the fact that it starts with a straight line of a radius, right, and then wait for it. There it goes. Starts with a straight line of a radius, and then they tilt it up, and then they wrap it around, right? So we use the radians are based on what the radius, the length of the radius. So we have to have some way of taking this straight line and make it curved on this circle, this unit circle. All right, so that's what this is alluding to right here. And this notation might look a little different. You've done transformations before where you've seen this arrow business going on. This just means transforms. So this is taking the radius, which is a straight line, and putting it on a coordinate of a circle. Right? So it's taking something straight and putting it on something circular. It's transforming it. Similar to like a rotation or a reflection or a translation or something like that. Right? It's just doing something of that nature. So this is how we write it. We give the name of the function right here. That's the name. It's just called W for wrap. And the notation is, what are you starting with? And what is it transforming onto? So each of these, we're just looking at that. Okay? So it's not too bad. I know it might look a little different, but here's what we're asking. So 3. So if I have a circle, go ahead and draw a circle. Maybe a little bit bigger for me. All right, we have some coordinates here. And we have this radius, r, that is wrapping around. Now the question is, if this is 3, a length of 3, where will this end up, right? And I could just say 3 like here, so the length really is arbitrary how I'm drawing this, but if I was to wrap this and have it go around the circle, would it stop? Where would it stop? Would it stop right here? 3? There's 3 right here. There's 3 down here. The question, that's the question, and we're trying to figure out what quadrant we're going to land in. So if you remember that, well, if we're going halfway around the circle, that's pi. Well, 3 would wrap right about here. So this thing, if I wrapped it around a length of 3, it would wrap around and end up in quadrant 2, right before the 180 degree or the pi radian mark. And that's all we're kind of getting at today, is just taking these lengths and wrapping them around and see what quadrant they land in. And I repeat, if it lands exactly like, say, right here, you just say not in a quadrant. Okay? Because the poles do not have quadrant labels. All right. So just do a few more. Pi over 6. So intuitively, what quadrant is pi over 6 in? You might want to think of this as 1/6 of pi. All right, so if this is pi, once again, and you broke just this whole thing into 6 parts, what quadrant would you land in? And then you would say 1. Yeah, if you broke this into 6 parts, that means this would be 3 here and then 3 here. Yeah, so this would be 1/6 right here. So that's pi over 6. That's in the first quadrant. So we have to have some number sense here with fractions and know where 1/6 is, right? And that'd be really close to 0. And then we have negative, right? So instead of wrapping above, I'll draw it over here. Instead of wrapping above, this is going to wrap from below, this way. So where does negative 2 over 3 pi land when you wrap it? So we know that, well, if this is pi, right, this would be pi over 2, right? That'd be halfway. So this would be negative pi over 2. So the question is 2/3, does this number right here, 2 over 3, come before 1/2, or does it come after 1/2? And you would say, well, of course 2/3 is bigger than 1/2, so therefore I know that this would wrap somewhere over here in the third quadrant. Okay. So that's just some number sense to think about. All right, you guys try. Usually on these, you'll see things are lettered. Those are my examples for you, and the parts that are numbered are where you guys actually try things. Okay, so go ahead and try those. You can work on them together by yourself, and then check with someone afterwards just to make sure they're accurate and you're all getting the same answer. If not, discuss, why they may not be the same and who's right, who's wrong. All right, so go ahead and do that. Take a few minutes and get that done. Okay, let's review. Number one, what do we get? What quadrant? Quadrant 2, yeah, 3/4. So we're like 3/4 from here to here, right? So that put us right around here, so that'd be quadrant 2. What about number 2? Quadrant 2 as well. That'd wrap us over here, good. And then number 3? Would be in quadrant 1, very good. So -3 would put us right here, not -3.14, but -3 is right there. And then if you add pi, that's, right? That's a 180-degree rotation, right? It's all the way on the other side. Or you could just imagine, what would this be, right? What would this be if you actually thought about pi as 3.14? Well, that'd be 3.14 minus 3, which is, well, where's 0.14? And that'd be right there as well. So a couple ways of thinking about it. Okay, so quadrant 1. Okay, so not too bad, right? Not too bad, right? If you already know the unit circle, this is another way of asking, like, what quadrant is, the angle pi over 6, right? So if you have that in mind, it does work. All right, then last part is thinking about the periodic function, which just means that as you go around the circle, it repeats itself, right? So we already know, since it has a circumference of 2 pi when the radius is equal to 1, that means the angles start over every time you get back to 0, right? We restart. And keep that in mind. Now, this next part has more to do with the symmetry of things. So go back to that original circle, and then if I said like pi over 3, if that happens to be, let's see here, pi over 3, if this is pi over 3 right here, which is some x and some y, we'll get into what those x's and y's are a little bit later. What is this negative pi over 3 if we wrap it the other direction? Well, I mentioned earlier that the x's will be the same, but of course, since it's below the x-axis, it's now going to be negative y. So the answers for these are going to be of that nature, where one or two of the coordinates become positive or negative. It's also possible for the x's and y's to switch, to have like y comma x. You saw those in rotations when you did that in geometry, right? So there's different combinations, but just want you to understand, you're not looking for numbers here. You're looking for, you're taking these, and when you transform it or you move it the other direction, what does that change about the answers, right? So same thing here on the next one, right? If we have, if we have this one, again, back to the same place, pi over 3, and we go 2 pi over 3. Well, that puts us right here, and now it's symmetric over the y-axis. So we have the same y values, all right, because we're at the same height, but now the x went from to the right, which is positive, to the left, which is negative. All right, so it helps to draw a little sketch or have maybe a unit circle in front of you, and you can kind of rationalize what the answers are without having the numbers, right? It's not as important to know the number as it is to know the relationship between these two. If you're on one side, the y-axis, what does that change about the answer? Okay, so you try the last one here, number 4. See what you get. This one's a little more difficult because you got to figure out how to get from pi over 6 to negative 5 pi over 6. Takes a little arithmetic to think about it. So, what do we get for an answer on this one? Anybody want to volunteer? Yep. Yep. What do we get here? Yeah, just say it. Thank you. Negative x and negative y. Very good. Opposite of x, opposite y. So if we're starting at pi over 6, right, we end up at negative 5 pi over 6, which would be over here. Really, that's a 180 degree. We just went from here to here. So, yeah, it goes from, like, let's say if this is like, I don't know, like 4 comma 1 or something like that, then over here would be negative 4 comma negative 1, right? It's to the left and down instead of right and up. So, again, having a little diagram will help you kind of justify your answer a little bit. So on each of your questions on your homework, they're going to ask you to draw, like it says right here, draw the wrapping diagram, right? So just to make sure you're not just guessing, but it makes sense on why that's the answer. Okay, so that's step 1, part 1 for your homework. Usually your homework is at the bottom. A lot of it's from the book. I'll post the PDF for the book as well, so you pull it up on digital, or you can bring your book, or a lot of people like the in-between of printing the PDF because they like the printed copy. They can write on it, right? And it's much smaller than carrying around the whole book. And I'll post it chapter by chapter, so it's very small, right? It's not going to be very thick. Second, this is an old book, so the answers, the odd answers, are in the back of the book. So you can always look up that. Okay. Part 2. Is let's look at the unit circle. This says quiz on it. For yours, it says quiz, right? So this is your actual quiz. It's just going to be on pink paper when I pass it out next week. And you're going to have to list all the radians, all the degrees, and all the coordinates of all these points, right? So today we're just going to do the radians and the degrees only. But I want you to learn it and see it by logic, not by memorization. Okay? That's the important part. So think about this and what we already know. Of course, we know this is 0 right here, and we know this is 180 degrees over here. Okay? And as we saw, we can and we can also take half of this and go only halfway, and we can get 90 degrees. I'll write it in here. We can get 90 degrees, right? So in the same vein, we can also just count by 90, say 90, 180, and we can get the bottom as well, which is 270. And it goes back to here, which is 360, which is the same as 0. So we know that much for sure, right? But we can also take the radians of it, which in this case would be pi, for 180. And if we can do 180 divided by 2 to get 90, we can take pi divided by 2 to get its equivalent. So pi divided by 2 is pi over 2. And we can count increments of 90, like I did all the way around. We can also count increments of pi over 2. So this is 1 pi over 2. You could think about this as 2 pi over 2. Right? Because 2 pi over 2 just cancels out, and you get pi. So in that vein, we can say, well, this must be 3 pi over 2. And then keep on going, and we get 4 pi over 2. Which, of course, reduces to 2 pi. Right? So it should make sense that we're counting by halves here. 1 half, 2 halves, 3 halves, 4 halves. Right? And we can do that with all of these. Right? There's a pattern here. So instead of just memorizing quick, like just randomly, like, well, this one has to be this certain radian, I want you to understand how logically to create it. So let's go back to, let's see here. Go orange. So we took half of 180 to get 90. Well, we can also take half of 90 to get 45. All right, that's 45 degrees. So we can take half of pi over 2, right? It's radian equivalent. Half of, and I'll do off to the side, half of pi over 2. What does that equal? Pi over 4. So that's why the radians for 45 is pi over 4. So the first time around we counted by 90s. Let's count it by 45s this time. So if we go another fourth, this one would be, this is 1 pi over 4. This would be 2 pi over 4, which of course reduces to pi over 2, 1 half. 2 over 4 reduces to 1 over 2. And we can keep on going. So this is 1 pi over 4, 2 pi over 4, 3 pi over 4. Right here. And this is 4 pi over 4. Which, of course, once again, reduces to just pi. All right, and just keep it going. Now we got 5 pi over 4. We got 6 pi over 4, which 6 over 4 reduces to 3 over 2. So you can see there's a pattern in how all these agree with one another. It's not just like a, well, just memorize it and just know it the way it is. You should be able to recreate it by pattern, which makes it a lot easier because you really don't have to memorize a whole lot. You just have to understand, oh, there's patterns here. Keep it going. Now we have 7 pi over 4. And then over here, 8 pi over 4. And 8 over 4 reduces to 2 pi. And let's just for fun go back and put in the degrees as well. We can add 45, get 90. 90 plus 45, 135. 135 plus 45 is 180. 180 plus 45 gives us 225. And then 225 plus 45 is 270. 270 plus 45, and we end up with 315. Okay, 315 plus 45 gives us the 360. So the way we count in 45s, we can count with the radians as well. All right, last go around. So we at 180. Right? Well, we have these other ones. These are like 30 and 60, so let's just look at this and label it 30. How can you get from 90 to 30? All right? Take a third, or divide by 3, which is the same thing. So if we take a third of 90, we get 30. So if we take a third of pi over 2, we'll get its equivalent. All right? So a third of pi over 2 would be pi over 6. So we got pi over 6. And we can count 30s all the way around, right, by adding 30. So 30 plus 30 is 60, plus 30 is 90, plus 30 is 120, plus 30 is 150, plus 30 is 180, plus 30 is 210, and 240, 270, 300, 330, and then back to 360, right? Just by adding 30 repeatedly. So, of course, if it works for degrees, it works for radians. So we can count by sixths instead of fourths. We can count by sixths. So we got 1/6, and we got 2/6, which reduces to 1/3, pi over 3. We have 3/6, which reduces to 1/2. All right, we got 4/6, reduces to 2/3. All right, we got 5/6, which does not reduce. 6/6, again, cancels out, equals pi. So you see how these things keep on iterating, right? Over and over and over. It's like we ran into 4 pi over 4, that's pi. 2 pi over 2, that was pi. 6 pi over 6, that was pi. Right? All these patterns mixed in there. Okay. Keep going, so that's 6 pi over 6. So then we got 7 pi over 6. And we got 8 pi over 6 down here, which reduces to 4/3. Right? And we have 9 pi over 6. Alright, reduces to the 3 pi over 2 once again. So then we got the 10 pi over 6. Alright, that reduces to 5/3. Then lastly we have the 11 pi over 6. And then one more time, 12 pi over 6 reduces to 2 pi. Back where we started. Right? And then we get back here, we go back to pi over 6. So if we go all the way around, remember that drops you where we started. If I take this coordinate and say, well, what's pi over 6 plus 2 pi? It equals pi over 6. Because if we have pi over 6 and we go 2 pi around, you're back to pi over 6. All right? Just put you back right where you started. Did a 360. Same thing if we went negative 2 pi. We'd go the other direction, but be right back where we started. All right, so that is the unit circle by logic and by pattern. And there's plenty other things here to look at to say, well, here's how I'm going to remember this. Here's how it's going to make sense. And a lot of people would say, well, something like this, like, well, these, got a lot of odds, like maybe 1, 5, 7, and 11, like 7, 11 or something might trick your brain. There's a lot of little things here that can give you ideas of what the right answer is. For the 45s, you can see it's 1, 3, 5, and 7, all odds. 1, 3, 5, 7, right? So look at this carefully and closely and try to find as many patterns as you can. The more that you figure out yourself, the easier this is going to be to memorize, because this is like your multiplication tables of higher math. You just want to know it just super quick eventually. Okay? Not necessarily right now or tomorrow, but by next week we're going to be pros at this. Okay? All right. So that brings us to your homework. So just a little note about homework. As I mentioned, it's usually at the bottom right there from the book. And you want to do this on notebook paper. Start by labeling it on this one. It's homework number 2, and then you can put the section 6.1 and then the homework problems that you have to do. So that way it's very clear. When I come and check homework, I'm going to say it out loud. I need to see homeworks 1, 2, 3, 4, 5, 6 when I check it. And each page is going to have the number on it, so it's very easy to know if this is the right one. Okay, so do put the number on it. This one's number 2. Yesterday was number 1, so it's not something I'll check by looking at paper. Obviously, that's just on the online. And then what else? The neatness counts. So you do have to write things neat. Write the question down so that you can use this as study. Some people do like the bare minimum, which always, for some reason, doesn't work out, but they keep doing it. But you want to look at your homework later on before the quiz or test. When you say, well, when I say, okay, make sure you review for your quiz, that means get out all your homeworks and look at them and make sure you remember how to do them. But if you don't write questions down, you don't know what your answers mean, you can't really review. This isn't a math class where, okay, the test is coming up, let me give you a bunch of problems to practice on. You just need to review. You just need to look at all your stuff that you've all done, and if you do all your homework carefully and neatly, when you go to review, it's very easy to review. If you're sloppy all the way through, reviewing is going to be very difficult, because if you can't read your writing or you can't do, it's going to be kind of hard. So there's a few people every year that have a tough time that they have to get used to, like keeping their notebooks, keeping organized. You know where everything is. 3-ring binder, so it's easy to find. So you can easily review and not adding all this extra work on yourself simply because it's disorganized or sloppy or missing. Okay. All right.